Our world and beyond. Space, in partnership with the European Space Agency.
Space, the final frontier. It may be the ultimate dreamscape with no known bounds, but it's also the ultimate hostile environment, where everything is extreme. To ensure we can send machines off successfully into the unknown, we've tried to create test beds on Earth. In Norwich in the Netherlands, the European Space Agency has built its large space simulator, a vital tool for preparing space shots.
The large space simulator allows us to simulate as much as possible on Earth what happens in space to a spacecraft. So you can say that right now you're as close to space as you can get without flying. Of course, we cannot simulate microgravity, but we can simulate the thermal environment and the vacuum of space, the different views of the sun.
Powerful light sources and a complex mirror array allows the reproduction of the different solar phases and the influence of solar radiation on the spacecraft inside the simulator.
This is not sufficient when we have a brand new technology to make sure, or to give the confidence that that technology will actually work as advertised. You really need to be in orbit. And that's where the microsatellite that we use in the Proba series came up. They help us to get the final validation for a technology.
The first Proba was built as a small test satellite orbiting the Earth. Relatively cheap, it looks more like a washing machine, covered with solar panels. 10 years ago, Proba 1 took off on top of an Indian rocket and was placed in a polar orbit 600 kilometers high. Its mission was to record existing radiation along its orbital path and test a new generation of batteries. Initially due to last 2 years, Proba 1 is still working.
In the case of Proba 1, which gave the name to the series, it was the autonomy on orbit of the satellite itself. And then we send out an AO saying, we want to try this. This is the spacecraft on which we're going to do it. Who out there is interested to use it for a mission, for a scientific mission? So we have what we call a payload of opportunity.
On top of the primary mission of testing, Proba 1 was instructed to complete a mission of scientific photography, monitoring the Earth. Its Earth observation photos don't have the high resolution obtained from larger satellites with optical instruments, but they are still very useful, opening up a range of applications via the use of filters across several wavelengths.
Proba 1 was initiated in 1998, so the technology evolves, so the things which we have demonstrated in 1998 are 13 years old, so it doesn't go as fast as mobile phones, but technology evolves, so the platform evolves as well. So the same principle, same size, same mass, but what composes the platform is of course more and more performant every year.
Proba 2 was launched in 2009 from Plesetsk on board a Russian Rokot launcher. It piggybacked alongside SMOS, another of ESA's observation satellites. Following the same strategy, coupled with the primary mission of testing a new generation of solar panels, Proba 2 had another scientific job to do. As it always had to face the sun, it was decided to take a closer look at it using two instruments, SWAP and Lyra. Our life-giving star is in fact an infernal machine. Its enormous ball of ultra-brilliant gas fuels itself from continuous nuclear fusion at its heart.
We live in the heliosphere of the sun, so basically we are in certain ways inside the atmosphere of the sun. And the sun, the radiation from the sun and the particles ejected by the sun, they completely dominate the environment around the Earth.
The sun goes through a cycle of activity with a minimum and maximum every 12 years. At the peaks, the energy produced can leap far out into space in violent solar eruptions.
They emit large amounts of electromagnetic radiation, X-rays, UV radiation, extreme UV. Sometimes actual matter from the surface of the sun is ejected into the space. If this kind of a storm hits the Earth, we can get an event what's called a geomagnetic storm. So we have actually some particles penetrating inside the magnetic field, and then one of the results of this is actually the nice aurora that can be seen in the northern Europe.
The aurora borealis is the visible and beautiful part of these eruptions whose resulting solar winds sweep the Earth. Unfortunately, there's a catch. The biggest solar tempests leave their mark in history, like the one in 1859 called the Carrington event, during which you could read a newspaper in the middle of the night in southern Europe, far from the North Pole. If such an event happens today, satellites will be the first victims of a massive dose of solar radiation. Next would be electricity transmission lines, with the risk of high-tension cables rupturing. All means of transport would be hit, and planes would be grounded. Today's world depends so much on satellites and energy that chaos would ensue. Some scientists are predicting a new Carrington event for 2013.
These major solar storms, or superstorms as they are sometimes called, they are individual events. They are not directly related to the solar cycle. And that's why basically at the moment we have absolutely no reason to expect that a similar event would happen, especially exactly on 2013, which is the next forecasted solar maximum.
Proba 2 is not the only sun observation mission, but it's adding its piece to the jigsaw of a new science that examines the telltale signs of coming eruptions and storms. It's a sort of space weather forecaster, and it's already able to give a roughly 48-hour warning of an imminent magnetic storm. This allows us to take precautionary measures.
In the long run, the Proba 2 can actually contribute to our overall observation capability of the sun, which helps us actually to detect these events, to predict the events, and also to forecast the events so that we can be ready if something significant is happening in the sun.
In the heart of the rural Belgian Ardennes is ESA's REDU monitoring station. It handles ESA's telecommunications and houses mission control for its space operations, notably the two Proba satellites.
Proba 1 is an Earth observation satellite which is in charge of taking a picture of the Earth, and it's easy to take a picture. You just have to tell the satellite the coordinates of the target, and the satellite will maneuver by itself everything which is needed to take the picture. Proba 2 is looking in permanence to the sun, and with two main payloads looking at the sun, and the stability and all of the control of the satellite is totally autonomously done on board.
Mission Control sends out the commands for each maneuver a satellite needs to make. Depending on the task each scientific team is asking of it. It is here that the millions and millions of bytes of data are collected from the onboard instruments. The data is then sent to the client, in this case the Belgian Royal Observatory, which designed and operates SWOP and Lyra, Proba 2's solar observation instruments. Operators and analysts then have to make sense of the jumble of figures from REDU and produce a readable interpretation scientists can use.
The data arrives here as a couple of files that the ground station in REDU sends us. But these files, they are in a complicated format. They are not in an image format. They're compressed. They have all kind of crazy details in them. And so here we depack the data and we extract it to make images of it that are useful both for the scientists as well as for the general public to watch and see what's happening on the sun.
More and more organizations and companies are using the images and graphs from Proba 2 for their space weather forecasting. They allow them to prepare for dangerous events and protect sensitive and expensive material from electromagnetic damage. The first 2 probers were built in a small company in Antwerp, which is currently building a new model, Prober V, V for vegetation. This 3rd model in the series is well underway and is following the same basic rules. It's relatively simple, robust, and it uses proven off-the-shelf materials. It will look much like its predecessors, but the mission will be different.
Proba 1 and Proba 2 were mainly technology demonstrators which had an Earth observation or a scientific payload on board, while Proba V actually started as an operational mission. So this was a big breakthrough in the Proba satellites family.
And that's not all. At ESA's Centre for Space Technology Research, R&D work has already begun on Proba 3. It's a mission that will involve several similar satellites.
In the case of Proba 3, we want to demonstrate formation flying. What is formation flying is to build enormous structure in space, which behave as a rigid structure, but in fact is composed by 2, 3 or more spacecraft, which are controlled one respect to each other.
The Proba saga is already 10 years old. 2 satellites are operational, and the 3rd Proba V will add its optical observations and should be launched next year.
With the first 3 probas demonstrated that this is really the way to go, and this effectively achieves what we want. They gotta stay small, they gotta stay fast, and they gotta stay cheap, but at the same time, we need to do more innovation, more innovative missions in this sense.
One scientific in-joke about the Proba series suggests they're little more than flying tumble dryers in space.
A very useful washing machine, yes.